And so now you're probably thinking, well, what do we do about this in terms of our teaching? And so for the sake of, our talk today, I want to break this up into content and pedagogy. But I want to also, just note that there's always a relationship between the two of these things. So it's not going to be something where you can just isolate content or pedagogy. And so for the sake of this talk today, I just wanted to say that content refers to what topics we cover in physics, and then also how we organize our curriculum. And so again, I just wanted to point out that there is a lot of physics education research that talks about gender disparity in physics. And the biggest thing is really talking about the types of environments that we are teaching physics or our students learning physics in. So what kind of majors do you have in your course? Who are the types of students are you taking? Are you teaching physics with calculus or without calculus? All of those things are going to influence the types of students coming into your course because of the level of preparation that we have going into undergraduate education from high school. And so one way that we can also do this is by teaching physics with history in mind. So as I mentioned, history is a very important and big part of equalizing diversity and inclusion topics. So discussing, bringing up where we get these ideas from and relating them to, women and people of color within the institution of physics. And if there isn't, I think it's also important to broaden that discussion of why that is the case. So for example, when you think about, who had access to telescopes and things like that, it's people who were wealthy, who were able to pay people to, create telescopes and study things like that. So I think a big example is trying to articulate topics within laboratory discussions. So asking questions about accessibility. So things like, you can ask okay, we talked about things like waves, right? So how does Wi-Fi work, right? And how do we create accessible Wi-Fi? So especially within Corona time, it's important to note that not all students have bandwidth capabilities. Not all students have access to, high-speed internet, even a computer. So those are all really important topics that you can use by putting them into discussions within chemistry laboratory. So you are essentially bridging the content with social issues. And so then when we think about pedagogy, it's why we cover topics and how we communicate those topics. And so again, there are a ton of different strategies to do this. So there are a lot of inquiry-based curriculums. There are process-oriented or guided inquiry approaches. And so those are a little bit more difficult to do within COVID times. But doing things like breakout rooms and stuff like that, where students can talk to each other and leverage each other as resources is important, because your role as an instructor, if you have thousands of students, you cannot be putting yourself in a position to legitimize every student's resources. But if you position other students as opportunities to, co-construct knowledge and guide learning, then that can happen within those breakout rooms. And I think it's also important that we talk about, how do you set norms and practices? So we can talk about and ask questions about that at the end. But, how do you rotate roles in a group? How do you make sure that everybody's participating? How are you, structuring the Zoom conversation to facilitate discussion? So is the discussion question have one answer where somebody could just be oh, this is it, Is there room for students to really discuss these concepts? And again, I think that engaging that within a social, within society, or asking questions about accessibility really broadens how students can, discuss these ideas. And so I also just wanted to point out that there isn't one solid approach to diversity, equity, inclusion. So for example, if we think about equity pedagogy, it's about talking about, what the resources that you have in your classroom, whether all students are able to access those resources the same way. So for example, is your homework system priced appropriately? Are the textbooks that you're using, can they be purchased from like secondhand sellers, things like that. So those are questions of like, do I have closed captionings on my videos? Do I have the ability to, ask these questions in different languages, stuff like that. And then critical pedagogy, as another example, is talking about how do we challenge those things. So I know that, there's a constraint within, so Purdue has the way that we structure a lot of our courses is we do it by major and non-major. And so for the majors courses that are for engineering, there's less flexibility in what we can teach engineers because it's governed by the School of Engineering. And so I understand that that also those power dynamics exist in probably your context as well. But just trying to say like, okay, so how can you incorporate, I guess like everyday physics as much as possible, but not just like, oh, there's a car crash, but more like trying to push in terms of like, who is these car crashes tested on? So like, for example, women are more likely to receive fatal injuries within car accidents because a lot of the testing dummies are geared more towards men's bodies than they are for women's bodies. And I think it was only recently in like the 90s that they started creating crash test dummies for pregnant women. So they like had forgotten that pregnant women drive. And so talking about like, how do we incorporate those types of principles into things like talking about force and stuff like that. So again, if you have more leeway that way, you can take a more critical approach in asking these questions. And so I gave you some sort of examples here, but again, the biggest thing is building on this concept of science literacy. So not just, getting content and having an answer, but more providing like having students use observations and content to drive inquiry. So they can create arguments and write, they can synthesize ideas in lab reports and stuff like that to argue and motivate certain questions. And this is good because again, it's a cross-cutting concept in the NGSS. So it's important that students are able to practice these skills within introductory courses because they become highly relevant for things like continuing education in graduate school. So this is like related to building notions of science identity or physics identity and stuff like that, which again, you want to legitimize as many pathways to that as possible. So you're going to have a lot of different majors in your courses, or you might have students that might be from one major, like mostly, but that they can draw on different sort of expertises.